Hi everyone, so for today we are going to learn about the conservation of mechanical energy. Alright, so for the definition of the conservation of mechanical energy, it says that in an isolated system, the mechanical energy of the system is constant, or the sum of the potential energy U and the kinetic energy K of an isolated system is constant. So it means that E is equals to K plus U, which is equals to constant, or K initial plus potential energy in initial form is equals to final kinetic energy plus final gravitational potential energy. So for today we will discuss about one of the question from our lecture notes, which is the exercise 5.2.1. The situation is that we have a ball of mass 0.5 kg. It moved from the point A to point B, C, and also D. For the first question, we need to find the total energy at point A. Now look for the motion of this ball. So it is moving at point A. So that is why it has the initial speed, which is U equals to 4 ms negative 1. It is also at the height of 10 meter at this point of A. So we need to find the total energy. So at point A, for the total energy, we have the formula, which is UA plus KA. So it means that at this point of A, it will have the potential energy and also kinetic energy. Next, substitute the formula for the potential energy, which is mgh and also half mv squared. The h at point A should be the 10 meter, and the velocity or the speed at A should be the initial velocity given as 4 ms negative 1. Next, substitute all the information given, and then finally we will get the total energy at A, which is 53.05 joule. That will be the answer for question A. Next, we continue with the question B. So for this question B, we need to find the speed of the ball at point B, where the height is 3 meter. So this is the point B, and the height at this point is 3 meter. So now look at the movement for our ball. So it's sliding down from point A and then passes through point B. So we need to find the speed at point B. So continue for this solution. To apply the solution, to find the final answer, we can apply the conservation of mechanical energy, which also we can write in the form of summation for energy at A is equals to summation for energy at B. So what does it consist for the summation of energy at A? It consists of the kinetic energy and potential energy at A, and for the energy at B, it will consist of the kinetic energy at B and kinetic energy and the potential energy at B. Alright, so the kinetic energy and potential energy at A, we have calculated earlier, which is 53.05 joule. So the formula for kinetic energy at B is 1 over 2 mv squared. V now, it should be the speed at point B. So we can just write as VB squared plus 0.5 times 9.81 times 3. So right now the height at point B is 3 meter. So after we calculate, so we will get the final answer for the speed at B, which is equals to 12.4 ms negative 1. Next we continue with the question C. So this question C, we need to determine the speed of the ball at point D. Now the point is D here. Alright, so let's look what happened to our ball. So it moving downwards from A and then B and then upwards again until C and then finally at point D. So what happened at this point of D? So to determine the speed of the ball at point D, it means that at point D the ball is still moving. But at point D we have to take note, which is the height is actually equals to 0 because the ball is at the origin lah. Okay, next what can we use to find the solution is that we can apply again the total energy at A equals to total energy at B equals to total energy at D. Okay, this is following the conservation of energy, which is the total energy at each point should be equals. Okay, but we only choose 2 points only, which is the total energy at A is equals to the total energy at D. Okay, so the total energy at A we have calculated earlier, 53.05, and then the total energy at D will consist of the kinetic energy and also potential energy. Okay, so the kinetic energy, the formula is half mv squared, and the potential energy is mgh. Okay, but for the potential energy at D, the height is equals to 0. Okay, so h is equals to 0. So after we substitute all the values, we will get the final answer for D, the speed at D, which is equals to 14.6 ms negative 1. Okay, next we continue with question D. So for question D, we need to determine the maximum height of point C so that the ball can pass over it. Okay, so now let's look what happened to our ball. So it moved downward and from point A to point from point A to point B, and then upwards to point C. So we need to find the maximum height. Okay, please highlight the word of maximum height. So when any object move or at the maximum height, so it will temporarily stop lah for a while. So at that point, the velocity at point C will be equals to 0. The speed will be equals to 0. Okay, so to find the solution, we can use the conservation of energy, which is total energy at A equals to total energy at B equals to total energy at D, and also equals to total energy at C. We can choose any point, but since that we choose for the previous answer as total energy of A, so for this solution also we choose the total energy for A is equals to total energy at point C. Okay, so the total energy at point A just now is 53.05, and the total energy at C must consist of the kinetic energy and also potential energy. Okay, so for the kinetic energy, which is the formula is half mv squared, since that it is at the maximum height, so the velocity will be equals to 0. So we can sub the value for the velocity at point C as equals to 0. Hence, we will get the final answer for the height at point C, which is equals to 10.8 meter. Okay, so those are the solutions for our question exercise 5.2.1. So that's all. Thank you.